This video helps you learn how to use Google Earth Engine to display a satellite image. We're going to use Landsat images for this purpose. Landsat has been observing Earth since 1972. The program, initiated by NASA, has provided continuous satellite imagery of our planet for over 50 years, making it one of the longest-running Earth observation programs. The Landsat program currently has two operational satellites, Landsat 8 and Landsat 9. Landsat is a polar satellite that orbits Earth in a path that passes near the planet's poles, moving from north to south or south to north. The orbital path allows the satellite to scan the entire surface of the Earth over the course of 16 days. In other words, it takes 16 days for the satellite to complete its orbit and return to the exact same spot to take another image. The image produced by the satellite sensor corresponds to the portion of the Earth's surface that falls within the swath. A typical Landsat image covers an area of 185 kilometers into 185 kilometers of ground area. Many such imageries together, known as an image collection. Each imagery contains 11 bands, which cover a range of wavelengths. Now we will move on to the Google Earth Engine code editor, keeping in mind the concepts of image collection, and spectral bands. First, search for Landsat 9 data in the Google Earth Engine Code Editor's search window. This will lead you to the catalog of Landsat 9 images. For example, you can select the Landsat 9 Tier 1 raw images from the catalog. Copy the code snippet given and go to the code editor after closing the window. In the code editor, we will assign this code snippet to a variable, say L9 equal ee.imageCollection Landsat LC09CZOT1. Here var is the keyword for declaring a variable, and here ee.imageCollection is a constructor which create image collections from lists of Landsat images. By writing such a command line, the variable L9 is assigned with the entire set of images captured by Landsat 9 as of now. We will be able to display the number of images available with the L9 variable by using the size function. The count can be displayed by printing the variable using print function. After running the code, the number of images will be displayed in the console window. But here, our aim is to display a satellite image of a specific place. For that, we need to filter the data using a geometry, such as a point or a polygon. For that, we need to navigate to the area from which we want to retrieve the images. Place a point marker at the area of interest. Once you place the marker on the area of interest, AOI, a point geometry and its coordinate details will appear in the code window. Here, you can see the point geometry on the map and the corresponding geometry details in the code window. Filter bounds function with previously created geometry as the argument can be added to the previous part of the command line. This process is called method chaining. Method chaining allows you to call multiple functions methods on the same object, one after another, in a single line of code. This is the first part of the command line. When we add .filterBounds geometry to it, it filters the output based on the geometry. This means that when we use a dot and a function, it further filters the already filtered collection. When you run this command, the L9 variable will contain only the images related to the area of interest defined by the geometry. We can add more filtering options to narrow down our search. Filtering by date is one such option. We can enter initial and final dates to filter the satellite images. By adding the .filterDate function to the previous command, the output will again be constrained within a range of dates. By running this code, we get filtered data based on location marker and date range. We can also filter the data based on cloud cover percentage. The keyword cloud cover is used to specify the allowable percentage of cloud contamination present in the image. Such keywords specific to a satellite image are present in its respective metadata. So far, we have used the image collection structure to retrieve all images. Then we constrained the collection based on a point geometry. Next, we used dates to filter the data again. Finally, we collected data with less than 10% cloud cover. Next step is to filter the first image from the filtered collection for final display. We can display the details of the final image by using the print command with the variable L9 as the argument. Once you run the code, it displays the details of the image in the console. The details of the image include the satellite name, path, and row number, and the date of acquisition of the image. There is a unique image ID is also available. There are 17 elements associated with an image, which include 11 bands and 6 supporting files. Properties are metadata associated with the image product. The image can be displayed using map.addAlayer function with L9 as the argument. Running the code will display a dark image in the map window. The image display can be enhanced by assigning the minimum and maximum display values within certain pixel ranges. Since the image is a raw satellite image, the selected values should be digital number values. The range of 0 to 12,000 is approximately chosen through trial and error, and any values outside this range will be clipped to the minimum or maximum display value. This adjustment ensures better contrast and brightness in the image. This concept will be further explained in an upcoming video that covers the histogram of an image. A layer name can be assigned to the displayed image using the same command line. The layer can then be activated or deactivated as needed. It is always a good practice to center the display on the geometry created. For that, the mapped center object function is useful. The function takes 2 arguments, the geometry name and the zoom level. When you run the code, the display will be centered accordingly.